Okay, so we'll get started. This section is going to be about temperature. So 6A. So we're going to talk about first is thermal energy, and we talked about it last unit, but to be more specific about it, thermal energy is really the kinetic energy of molecules. So if you have a bunch of molecules, tiny particles, and they're vibrating back, they're anything as long as it's not super cold, they're going to be vibrating back and forth. And it's that kinetic energy of the molecules that's really what is thermal energy. It's what is made up of, or it's why there is thermal energy. So again, thermal energy is the kinetic energy of the molecules, so the very small particles. And what temperature is, so temperature, that's the average molecular kinetic energy. So if you were to look at an object, all the molecules in an object, some of them are going to be moving fast. Some of them, let's say over here, are moving pretty slowly. Temperature is basically, we'll take an average. We'll, average them all together. What's like the standard one doing? How fast is it moving? That's what temperature is. So again, it's an average of really how the average amount of energy that's in all of the molecules. Temperature, I know you're definitely familiar with it. It's measured in one of three scales. So each scale is going to have its own standard unit. There's the Celsius scale with degrees C. There's the Fahrenheit scale with degrees F. Then there's the Kelvin scale, which it's technically not degrees Kelvin, it's just Kelvin. The standard metric unit we're gonna use is degrees Celsius. So again, unless it specifies otherwise in a problem, you're gonna put degrees Celsius. So the temperatures, the different scales, they can be converted with two equations. So with these two equations, with some combination of them, you can go from one scale to any of the other scales. So there's one for getting degrees Celsius to Fahrenheit, and there's another one from getting degrees Celsius to Kelvin. And again, just kind of simple algebraic equations. For this class, you only have to know really two big temperatures, and then you could convert if you needed another scale. The first one's the freezing point of water, right? That's 0 degrees Celsius. And then the other one's the boiling point of water is 100 degrees Celsius. So those two you definitely got to know. Not really too many other temperatures. And the last thing here is it's kind of a physics situation. It's kind of theoretical. But if a molecule were to stop moving completely, it would have 0 joules of kinetic energy. So let's just pause there for a second. So again, all molecules are moving very slightly. It's hard to see sometimes, but they are moving. Theoretically, if you could get a molecule to completely stop moving, it would have no kinetic energy. So it'd have no kinetic energy. It would actually have no temperature either. So we'd say it would be at absolute 0. And that's measured, that would be on the Kelvin scale. So again, if you could stop a molecule from moving completely, meaning get rid of all the kinetic energy, really, so all the, wouldn't have any thermal energy, you'd say it's at absolute 0. And it's very hard to do. That's not something you'd normally see, but that could happen if you removed all of the energy. So, again, kind of a short unit. That's all of the things for temperature. So again, the thermal energy, right, is the kinetic energy of molecules. Temperature is an average molecular kinetic energy. So if you were to pick, like, I don't know, the average molecule and look at its kinetic energy, that would be temperature. There's 3 scales to temperature. You could convert between the scales. There's 2 temperatures you get to know, and talking about absolute 0. So let's actually see a problem now. Here we go. So what is 0 Kelvin? Notice it's not degrees Kelvin, it's just Kelvin. What's 0 Kelvin on the Fahrenheit scale? So we want to go Kelvin to Fahrenheit. Degrees Fahrenheit, technically. So to do that, we're going to have to use the equations to convert. So there's one equation that will get you Kelvin to Celsius, and then there's another one that will get you from Celsius to Fahrenheit. So we're going to use we're going to do these in order. So we're going to go from Kelvin to Celsius first. So the first equation, it says Kelvin, I'm just going to write K, is equal to degrees C plus 273. So what you're going to do is you just plug in 0K is equal to degrees C plus 273. And we subtract the 273. So it's going to be 273 is the degrees Celsius. So that's not the answer, but that's closer. So negative 273 degrees Celsius. Now we want that in Fahrenheit. So we're going to use the Fahrenheit equation, the Celsius to Fahrenheit equation. So that's degrees C is equal to 5 divided by 9 degrees Fahrenheit minus 32. So we're going to plug in what we know for Celsius. It's negative 273. It's equal to 5/9 degrees F minus 32. We do the math out. We divide both sides by 5/9. We get 491.4. It's equal to degrees Fahrenheit minus 32. And then we'll divide, or not divide, we'll add 32 to each side. So we'll get what? Negative 491.4. Negative 491.4 degrees Fahrenheit. So again, we have to go from Kelvin to we want Kelvin to Fahrenheit. So we're going to go Kelvin to Celsius with one equation, and then we'll use the other one for Celsius to Fahrenheit, and this is the temperature in degrees Fahrenheit. So that's it, kind of a shorter unit. That's all for now.